All right. Right now in this classroom, there is no students, but I projected it on the screen. In that way, the people walking by the classrooms may be able to see we are having a class. And also to you on Zoom. We learned the language Swift, but we didn't do yet the user interface. So Swift UI is a okay. Swift UI is a user interface. It's a very nice user interface. So not all the UI widgets will be covered. Of course not, because it is impossible to cover everything. But I will give you many the useful and frequently used widgets. So you may be able to use it most of the time. And if you want to bring more widgets, there are lots of widgets possible, right? So you can the exploit on your own with the skills that you learned from this class. So this is a Xcode IDE that you may be able to see. We opened it a couple of times. So today we will do the multiple Xcode file creations. So simple app is a button, right? So we can see some of these. For example, we can import SwiftUI, first of all. And then this is a structure format, which is similar to a class, which will be a type, therefore, for additional the class that you want to define. So content view is the name of the file that we want to present, right? So this you name it, content view, and then we say that is nothing but a view. So this is a type. This is already defined, right? You simply use this view. And then there is a body and some view, as we looked at. This is one of the view that we creates. So if you see, where's my, okay, here. We'll look at this a little later. This is very, very important. And this is nothing but a variable count, but private. You can say, or you don't need to, but you don't need to say either private or public. State, this is a very, very important modifier. And then the body of this content, body of this view is some kind of view. There's a vertical stack. So this view may be vertically displayed. If this is your view, the screen, then something can be vertically displayed. In between, there is a 20 pixels. And then first thing is a text. So you want to put here text, whatever it says, right? So it says simple counter. And then there is a text font of that text, like a method invocation. So when you do this text is a class already defined, what simply we use. Using this text initiator, or we call that instantiator, if you recall Python, then there is an init method. There's a double underscore, the method already defined. We simply use it. So underscore underscore init underscore underscore. So that is the definition of the initiator. So when you simply call that the class name text with the string, then it creates an object of text. So what it appears here on your view, that is an object of this text class. So this is an object. Object dot method. So that object invoke a method called the font. This font, the method defined to set the font. The size of that font is the large title. This is already defined. Everything here, this method defined. This value also defined. Dot large title. So that is a dot notation. There, maybe a dot notation can be used to invoke a method. Then that we say object dot method, or we can access a field because in object orientation there are two aspects of representations, static aspects and behavioral aspects. Static, therefore, we put that some of the attributes to associate it with the class. So this is the way that we can access dot large title. Unlikely from Python, a way of invocation or a way of accessing. Here, Swift is really handy. So we can simply, from this object dot method, we can continue to attach dot method. Dot notation can be attached to it, rather than having, for example, object dot method. If we want to invoke another method from the same object, then we need to make another statements. Object dot method, object dot method, object dot method. We continue to do that, repeat that. But in Swift, simplify that. So once you have this upfront, and then we can attach dot method, all the invocation of this method is about the object of the object that appears upfront. So weight, font weight, there is another method. So dot font method take this value. Dot font weight takes the bold, that type of things. Okay. Let's see if we need to practice this. Little bit of practice, okay? So let's do. Let's start with the Xcode and then create app, and I would say in class, and I would do my first UI. Next, and save it on this folder. Okay. to push this to the side a little bit. And I do not need this. Instead, I put vertical stack, and I put here spacing 20, and then first text, I would say simple counter. Then it appears like this, simple counter, right? But as I invoke font, and then I can say the large title. Then it became large title, right? And then I want invoke another font weight. And what kind of weights that we have? So bold. So dot bold. Then it will be bold. That's what happens so far here, right? So vertical. So after we have a vertical, I want to make a horizontal. Okay. And the next one is horizontally, that I have, for example, image, text, and image. So I want to put here image and text and image horizontally. That's what I want to do here, right? And the font, again, there's a dot title too. So if we want to do that, then next one is horizontal stack and spacing, again 10, and then I'll put text count, then it appears count, right? But I want to make a font, say didn't give me any options, unexpected indent, or not this. Oh yeah, it does there. Font. Okay. Then I have somewhere title 2. There's a title 2. This is a vertical and a horizontal here. So I want to put the image at both sides. For example, image. And then there's a system name. This guy already know. Minus dot circle. System name minus dot circle and plus dot circle. So minus, but not just minus. I want to put that as circle. And similarly, then I have here minus 1. There's a minus. And then image. And system image. And there's a plus circle. You can see where should I download? I'll show you one. application that I downloaded, but I'll show to you where you can download. That is series modified today. Let's see. Right. This SF symbol.app needs to be downloaded for your convenience. Then you may be able to see some of the system level images. See here, there is a plus circle. Then you may be able to see. Let's see, this is all right. So I can see here plus. There are all different kinds of a plus. The one that I used was plus.circle. But if you want to do plus capsule, that's fine too. So instead of a circle, if you want to do capsule, do you see the difference? This is a circle, minus a circle, minus dot circle. This is plus dot capsule. So those things can be found if you download this. So you can download it from, for example, it is called SF symbols. So if you go somewhere here, then I think SF symbols, Apple developer. So if you click this, then this is the things that they already developed, already downloaded, right? So you can download from there. Okay. Then you can use some of the system images. There are so many good things that you, or many things that you may be interested in. Then you can use it. Okay. So what happens here? This the horizontal stacks is the second item of this vertical stack, outside of a vertical stack, right? So we could do that, and then there is a there's a button. We can do. This is a vertical stacks. If you, this is the well indented, but if you want to figure out where it is, then if you put your mouse on the open the curly braces and double click, then you can see, oh, this is from this highlighted is the block of that vertical stack. So if you want to add additional item within that vertical stack, then you need to put here and then make another item there. So for example, we have another hierarchical stack. So I want to this time choose this. Not really. This is no good. Okay. Stack, and you can do spacing. Maybe in this case 20, and then I have items for that hierarchical stacks. So I want to put button, and then I can say add, and the button, once the button is clicked, then what is the action that I want to do? Then I want to add, right? Because that is the add button. See here, that is plus button here and minus button there. Whatever. Maybe. So let's put this. So plus first and minus later. Plus first and minus here. That makes more sense, right? Plus here and then minus. Oh, there is no minus circle? Let's see. Minus. Oh, there is no minus. Capture. Interesting. Let's put a minus. Then I will do plus capture and minus. I want to put some minus circle, maybe reasonable, but minus rectangle, minus diamond. Diamond I may be able to use for maybe divider or multiplier. I want to put the circle. Yeah, that's better. So I want to make this circle. Then this is a plus and minus. Okay. So we want to count, and that count needs to appear here, right? So in order to make it, then we need to declare the count here, right? So variable count, say that is integer 0, that's fine. But there is a state, @ state. This is special things that I explained in the later slide. So let's jump into that place and take a look at one of those is a state with the collections. UI updates when array changes. So it's having this state, we can change that values. And somewhere that I made here, state, variable state. In SwiftUI, views are struct. So we have a struct like a counter view. And the struct are normally immutable. Because of this struct, if we do not have a state, then it is not immutable. But we want to make it change, right, as we move. So UI needs to change the data. In that case, we have to put @ state. @ state is for local and simple state owned by a view, this view, counter view. So for the number, string, booleans, and struct, SwiftUI stores this value outside the struct, so it survives with refreshes. So if this count stayed within this view, counter view, it stayed there, never changes. That is immutable. So when we have this, then this count may be stored outside this view, so it can be mutable. Actually, that is what it happens. So that is a state. Okay. Then there is another similar ones called @StateObject. This is something that even that appears the later slide. So we'll cover that today also. So back to ours. So we need to, at this time, we simply say we need to use, where is it? No. Okay. So we simply make it mutable. Let's say that without that, let's see what happens. So if that happens, then we can say counter and then plus equal 1. Okay, it can be counted 1. When you put here counter, it's a count. And it says left side of a mutating operator isn't mutable. So this, when you do this, our operation is we want to add to the current number of a count, and the count will be mutable, will be updated. But this count is not, cannot be updated. By this point, we do not know why, right? That is because this struct, the frame. Within that struct frame, the value is owned by that frame, so it cannot be updated. But if you want to make it mutable, then you need to put here at the state. Nicely that disappeared, right? So without this state, then you have the issue, but in this case not, right? Similarly, we can do, we make a reset button. Then we say reset. And then reset is things count equals 0, right? That's for reset. Oh, this is a button. So another button. We can say subtract. Similar to above, count minus equal and 1. Remember that this plus equal sign, that is a syntactic sugar. So it is nothing but count equals count plus 1, right? If you do not know. And then this, the horizontal stack, I want to put their font. And title 3. This is a little smaller, right? So when I do this, the count. Okay. So in between this count, I put there really count, right? So I want to make this here text, right? This count. I want to make really, well, actually this is a plus sign, that is my minus sign, and I want to make this is the count. This is like a title, whatever that you see here. I think. And then we can do, let me put that all here. Oh, that's much better. So system size 100, weight dot black, design default. Is it? This is not exactly the same as that one, but this is something given by Xcode, Smart Xcode. Over the weekend, one of my niece, she's working at Apple. So I asked her, not like Meta or Google. Apple seems to drop some of the research on AI. So I asked her, is Apple a little bit behind in the artificial intelligence or machine learning advancement? And she said, not really, but once it was set back a little bit, and therefore seems to be that way understood the outside of Apple. But she said Apple may catch up a little more or collaborate with, I believe, Apple is collaborate with the Google. Strange. So Android and Mac, Apple can work together. What I'm saying that here, so a little bit of intelligent assistance here, doable, right? So we can say if this size is 100 is not good for you, then you can change it. Once you have something, then you can change it. 70 weight black, but if you do not want black, then you can do maybe something else. I'm not sure. Is there pink? Pink is not the word. What about blue? Wait. But black works? Oh, here. Oh, only this. Black, bold, heavy, lights, thin. Oh, this is not just the color. Oh, I see. So let's do black. By this time, see if it works. When I do this add, oh, nicely. When I reset, 0, subtract, add. Very nice, right? So this much easy, sometimes easy to make a user interface on iPhone apps, right? We didn't do much. We simply did a little bit of those, and then the effect of our coding may be maximized, right? We didn't do much, but the beauty of the user interface is really great. Oops, why? Oh, this is not a scroll over. Okay, so this is a little bit of the tasting of the user interface. So we'll do more. We can put there, for example, if you want to change the task, then if you want to declare the task as a variable, which is an array of some of the task names, then you need to declare in this way, right? And when binding, that is another thing that we need to be aware. Binding, so state is one thing, and the binding is another. So if we move, that I explained also somewhere here, binding. When you put binding, it means I want to pass state to child view. Child view should not own parent states, but instead get some reference. This is the difference between inheritance and binding. Remember that in object orientation, you can create a class, superclass first, and then you can make a subclass. That's fine. In that case, the property owned by superclass can be inherited to, it is inherited by the subclass. Like in our daily life, the property owned by my father eventually inherited to me, right? Then who's the owner? Something inherited to me will be owned by me. There's ownership changes. If you want to change the ownership, then you can simply struct superclass and subclass. That's fine. However, that is a typical programming languages. That's what's happening in Java and also Python. But if you do not want, there's some other cases rather than inheritance, saying that, hey, I have my father and myself, so we have some relationships, but I do not want to inherit, but I would simply use my father's property. So I want to pass some data to my father's property, pass back and forth, rather than inheritance. There's some situation that we want to implement that, right? That's not possible in Java. It's not possible in Python. Therefore, Swift make both available, either inheritance or binding. So once you make binding, look at this. This is the view, and this is the child view. Here above, there is a name. So of course that is the states, and then this guy wants to. I want to put child. Then child, the same name, is binding, meaning I want to reference my father's name, although I declared the variable name at my side. It is not owned by me, but I want to report to my father's name. That's what it is, right? That's a binding. This binding is a reference to a single value. There's another things that we will look at also. Observed object, similar to binding, but in this case there's a observed objects. It's more like the model. Model means in this case the values, right? Not just a single value. If you want to work on single value, then you can use at binding. If you have whole kinds of structure, the values, objects, then you need to use observed object. It sounds like objects, right? This is single value, this is objects. That's what we had here. State objects. So store symbol, simple value type owned by a view. So you want to save it, right? If you say state object, then store reference type models that must be persist across read rows. Like this can be revalued, updatable, mutable, then you can do state. If you want to do read row, like some of the user interface, then you need to use state objects. So it's at state and at state objects. There's some of the correspondence. Similarly, here are binding and observed objects. There's some correspond. That's what it is. Declarative list. You can make a list also, right? In this list is some of the data handling mechanisms and open and curly braces. So rather than having a iteration in typical programming paradigm, then you can have a for loop, right? Then you need to have a for, open parentheses, initial states, and some of the final states, and some of the steps. You can describe that way. And if you have a for each, that's fine too. But in this Swift, particularly user interface, particularly in view, like this view, that iteration is not possible. I mean, that iteration, the language doesn't fit to this user interface. We want to handle a little different way, in a different way, not the way that we used to understand for a loop, but in the graphical user interface. I mean, inside the UI, then we need to have here something different, like a list, and for each. Let's say if we have a task which is an array, then we can say, see here, this uppercase for and uppercase each. That task and ID by itself, and then we can say this is for each statements, and then for each what are you going to do? Then we can say this is my local variable task in text task. Then for each element in this array, I call it element variable task, and that element can be listed like this. Okay. Shall you practice this here as a simple practice? Then we can say here, so attendee, I'm trying to say that is a list string, right? String attendees. This is automatically came up here. So I say John Samrat Victoria and awesome, whatever. Okay, so I declared that attendee. And if I want to list it, then I can say everything from above here, then that is, oh, this is horizontal. So here that is a vertical, right? All the way here. So I want to make here, say list. Oh, this guy is really intelligent. That's names. Very, I didn't do much, but already gave it to me, right? So we have John, Samrat, Victoria, awesome. Okay. Very handy, right? We don't do much, but the effect of that is really tremendous, right? So beautiful. Are you guys following me, or you are? So silent. I don't. Okay. Looks like you're okay. If you're not, then you can. Let's see if there is any. Oh, I have 3 students. Oh, myself. Chat. So far, so good. Okay. User triggered some of the buttons. Remember that we already did that, right? Buttons, some of the triggers. System behavior for free. We don't do that yet. Okay, move further. So that we have a little bit of those. So I want you to do not only as I put here, add, reset, subtract. Can you make it, what did I do here? Oh, double. Yeah, double, triple. What did I do? Double, triple, and it's not really clear. Oh, half. Can you make like this? Double, triple, and half. You can add a little bit here under. I'll be back. I need to go to restrooms. I'll give you 2 minutes. Okay. Here is so this is yours. Somewhere here, this is 11. I want to fill out yours. We don't have to worry about this. This is this. And then the signature. Okay. So how's it going on at your side? Samnar and Victoria. Is it good at your side?
My side is pretty good.
Good. How about Samrat? Oh, It's silent. Okay, here. Chat. All good. Okay, good. We may not need to do that, right? I think. You can repeat this similarly. Similar with this, you can do copy of that. Then you have add. Instead of add, you can do maybe double. Then I think it should be times and 2. And therefore, if you click add 1, then that is 1. If you double it, right? Similarly, you can do something else. Done?
Yeah. When do I return this?
At the end of this semester. So we'll go all
Work
together.
on my laptop and everything, right?
Oh yeah, you can
Also-
freely use it.
You're saying something, so I stopped. The Monday lecture, did you record it for the Raspberry Pi download?
Installation and
Yeah.
configurations, yeah, already recorded and posted. So follow that.
I'll just do this, try to download it. If I cannot, I'll just come on Monday and ask for help. I will try.
You will do. Yeah, you will do. There's no
I
issue.
don't know what the device looks like. It seems. Yes.
I want you to open it
Oh.
by yourself. No, you can go and
Yeah.
open at home.
Oh,
Yeah.
thank you, Professor, for bringing
Yes,
this.
yeah, enjoy it. Yeah,
I'll see you later.
no problem. Okay, so let's take a look at some of the widgets, right? There are a lot more than this, but I would say top 20, the UI widgets, navigation stack. We will may be able to use this. What happens, this navigation stacks, if we want to click this, it goes to next view. Can navigate from view to another. That is very common, right, in your hands-on UI. Table view, if you have this list, this is kind of a table views. So table has the multiple rows and columns so that we can make some of those. List we looked at just section. You want to make a section by sections. Let's see if we make a section here. Section. Wait for it to section. That is an issue. So section, then we'll do this later. Okay, so and text, yeah, many. Let me just read it. Text, image, button. Some of these we use the text field and secured field. The text field is simply the user entered, and then the type entered. The characters entered by user can be displayed, so you can see it. Secured field, like a password, even if you type, the type the character shouldn't be disappeared, so we put there asterisk. And toggle, picker, date picker, slider, stepper, progress view, label, link, share link, toolbar item, alert, confirmation dialog, sheet, scroll view, lazy vertical grid, navigation link, context menu, a lot more than that. I believe we looked at this already, right, at the state. And also we practiced this. And binding, we also, did we practice? Oh, we didn't practice this yet, right? This is a superclass and subclass case. So for example, parent is a view and child also a view. In this child, I want to use, but actually in this case, we don't do this parent and child. There is no structural definitions. It's not like this. Struct child, when we create a child, type of child is parent. Then parent is a superclass, child is a subclass, having this. But in this case, we don't, right? Parent is a view, child is a view. But why we say parent and child? That's because one of the values declared in one view, and from another view, the same value needs to be referenced. In that case, we can see here binding. Okay? This is a superclass and subclass hierarchies having this. Okay, this is a hierarchy, inheritance hierarchy. So parent has a name, child can edit it in two ways, inheritance style or SwiftUI binding, $binding styles. So I want you to try. This is something that we try, I want you to try, but here we can do this quick. Okay. So I want to create another. What is this? Oh, I want to try. And then I can do in class binding or inheritance. In class underscore binding underscore inheritance. In that way, you don't forget, right? Or we can put some, I want to put timestamps. So 02, 25, 25, 26. Text. Okay. I would say here, let's say parent. then immediately it says cannot do parent. So of course, in this case, you want to do parent. Then you will have that. And then text, remove this. Text, I would say parent sees some of the names, but name here I want to declare it. Say I want to change this name, right? As this child, the other view can see it and edit it. Then I need to make this a state, and then private, and I would say text name, and then name currently say Mercy. And then I want to say here name. Then you can see Mercy. Hello. What is there? Cannot find content. Okay, sure. So here, this I changed, right? Parent. So I need to change this parent. Here, enter. And then there is an error. So if we quote here the main, this is entry points. Then we need to put here the parent. Come back here. Let's see. This is okay. This is a parent sees Mercy. This is somebody's. Why just late?
It took me 2 hours and 20 minutes to get here.
Oh, I see. So we have 50% online Zoom right now. So
Okay, did you turn an announcement or something?
no,
I thought
because this is. Okay. Yeah, if you ask me, then well, these students remember those students.
Yeah.
So I set it up Zoom. Like you, if you
Okay, what about the
yeah, then you can
to be in?
yeah. For some reason, if you cannot come, if you ask me to open Zoom, then I can open it. Like this time, if it give you right some of the traffic issues, then yeah. But anyway, let me know early, then I can make it.
I checked the messages in the morning. But
Yeah, I didn't. Yeah, right. It's a request based. It's not officially all the time we put Zoom. Partly because when I have a Zoom and when I record, then my laptop is not that much strong. I mean, powerfully enough to cover everything. At this stage, earlier stage, it's okay. But later, if we put more and more functionalities connecting to outside, then from my experience, sometimes my system is hung. So to avoid that, yeah. But today is okay. We don't really do much.
The homework 2 again. Because
Oh, that yeah, I remember right. when you make a zip, you need to make the top level zip. For example, here, this is the top level.
Yeah.
This is the top level. How to know this? Then you need to go back to your the storage, whichever that you saved. Right here. Let's see. Did I? Yeah. Remember here. This is that one. So come back here. You need to make a zip of this. Compress this. Not any inside. Right. Do not make any copy of any of. Yeah. Do not make a copy. But compress as is the top level of your project. Unless otherwise, it cannot be run on my system. Yeah, yeah. Yeah. Yeah, first time, okay. But if you keep doing that, then it'll be a problem, right? Okay, so where are we? So here we have a parents. Parents see that, okay. So parents see the name Mercy. And I want to, this is one, the struct. So I want to make another struct. Struct, if there is a parent, then we can say maybe friend. It's not necessarily parent, right? It's simply, no. This is observed object. This is really, okay. And then we need to have a var, body, some text. Okay. But I do not want to hear like here. I want to text to then name. So rather than simply repeat that, I want to make a text field so that I want to type some. I want to type something. Okay. So friend can edit, because that is the edit. So I can say there's a text, and I want to use the same name that was defined here. This name. I want to change it. I want to see my parent's name as a friend, but I want to change it rather than the value that I can own. Okay. In that case, we need to put here bind. Binding variable name. There's a string. So this name and that name should be the same. And then I can do here invoke the style of that text field. So text field style. And this is a rounded border. This is rounded border text style. So I want to make this as is. So rounded border. Let's see what happens. It's not automatically rendered. So let's try to see, let's get some of the emulator. Okay. So right now that is iPhone 17 Pro, so I can run this. Why I have two? I'm gonna change. Oh, yeah, one thing that I need to do. Yeah. Like here, after this, I want to run friend name. I want to send the name that I defined here. So currently there is a mercy, but when I change this, see here where I am now. This text field is the child, the friend, right? It's not the parent itself. As a friend, I want to change the name. Then this name is not the name owned by this friend, but name owned by parent. So parent name is changed as the friend modified it. So you can do John. Things like that. So this is very handy. So in that, this is not really hierarchy, but from one view, see there's two different views available. Variables can be declared in one view, but I want to allow the other view to see it and change it. If it is changed by my friend, then it is changed mine, because the value that I allowed my friend to see is not owned by my friend. So if my friend see it and update it, then that update is my update. That is a binding. It's a tightly binded, right? That is a binding. Can be done a little bit in hierarchically, right? Like this is hierarchies. So try this. Let's see. Oh yeah, I have that in next slides, but I want you to practice it from this. So actually, parent has name variable, and child is subclass of parents. That's what it is. And then this class declared a function. Actually, there is a method of that class. The method called change name, and name equals that, can be modified. If we have two classes and one superclass and the other subclass, and then I can make a object of this child class. This is object creation, right? Child equals child. And I can print this object dot name, then I may be able to see this name, right? that type of things possible. So I can make another. In class. Like binding effect using inheritance, that is my goal. But I want to do as a practice simply say, well, actually this is a print state. Print cannot be run here, right? So even if for that, we can simply try to practice parent and then variable name equals mercy, and then class child parents, and then I can create a method func change name and name equal John. Okay. And then I want to make this here. Of course, I need to change this too. This is okay. I want to make here content view anyway. Struct content view. Hello world. Let child1 equals child. So child1 object is created. Child1 name, change name. This is practice. Is it expression not allowed at the top level? Maybe because of that. This is not print statement is not available on SwiftUI, right? This is, I mean, not that is available on the playground. Actually, on these hierarchies, I want to, let's see if I can place this on here. And rather than this, I want to do text. Because this is not possible. I want to practice this. So hello world here and ch1.name, then I have a mercy, right? I didn't do, let's see here. As a child, I put here child. ch1 is nothing but the object of child, right? Object of child, let's say this is, I don't have this, okay, for example. Oops. I want to make this, this change function is not defined. Simply parent name is Mercy, and I said child is a subclass of parent. Therefore, I want to see parent name is inherited. That's what I want to test here. So I will run this. Then I know this child object, there's nothing about the name, but still I can get the name from my parent. So I have a mercy here, right? Rather than hello world, then I can see the relations in inheritance hierarchies. So that I have here. And I want to see here vertical stack. Spacing 20. I'm going to make both under my vertical. So I have a little bit of a space here, right? And this may be font and large title. Okay. Okay, now I declared the method. So what I am trying to do is to, for example, another text. I want to copy this. I will do. And I will do here change name. But a little bit of the thing here, I want to make to string so that it'll be return name, then it'll be returned. Okay. the most, I want to focus here. The first text here, simply before we inherit, the child has the name, which is inherited before we updates. And then in the child class, there is a function, the method, where we want to change it. So we invoke that. As we invoke, we want to return the value string, right? So it'll be changed. If I do here text field, I'm not sure. Is text field possible here? In this case, we need to put binding. Let's say cannot have that. So cannot find this. So we put here a name is true. This is not really, this is outside this view. This class has no view, but this text field is a view. There's a reason. So in the next, so a little bit of this we emulated, right? If I return that, then it is simply this. Name equal John. Name. This is what we had. We don't need this, right? This is a simple one that we looked at. Okay, next slide gives you a little more formal way of using here observable object. So parent model is observable object. There's a child model, there's a parent model, and then there's a struct. So a little more complicated ones. For this, we need to understand these observable objects. And then here state objects. Right. These things is needed. But we'll you can do this a little later after we looked at. So property wrapper. state objects, observed state, observed objects, and the environment objects. State object is very similar to states, but it creates and owns a model, which is a, as I looked at here, where did I have that? Oh yeah, here, state object, it stores and reference types that. So let's look at this. So observable object and observed object. Observed object is very confused right now, right? So don't worry about that. It takes time. It's like a binding. Binding, we are considering single object. But if we have the data type itself, then we can observe the object declarations. In order to get that, the struct first declared as a observable objects. So observed objects and observable objects are matched together. Okay, binding and state matched together. So back here, observable object and observed objects. Other thing here, observable object is a model itself, model type. So when you declare structure, then you need to do observable object. This is something if you want to view that observable object, then you need to use the observed object. I know still it's not really clear, but we need to look at this. Observable object is a data source itself. If we have this already, then we can, if we want to view it from other view, then you need to use observed objects. This is a subscriber, not the provider. Provider here, observable objects. This is a view. Inside the view, then you need to use this. Rather than understanding the bullet items there, the best way that we could do is to practice. Okay, so we need to practice like here. So in the model, we need to do we need to define observable objects. Like here, when you define class user model, then we need to define observable object. So this model is created. In this model, name is John. So publish this like a private public, then we published. In order to view that, this is a view. Inside the view, if we want to reference this name, then we need to here observed object, because we already had here observable objects. The value inside, I mean this model itself, if we want to reference it, then we need to do here observed object, and variable user is nothing but user model. That. So we call that user. Because we call that user, we can access whatever the element declared in this class accessed. So user dot, again here in this case, dot notation. So user is a reference, like an object. So object dot name, object dot attribute. user.name. This name is nothing but that name. That is exactly what we have here. Okay. So I want to close this again and create another project. And I call here I would say objectable and observable object, not objectable. Observable and observed. So observable, we need to create observable model, which is a class. And then in the view, we have to do observed reference. It's not really easy to understand, but that is the new concept. So let's look at here. So we create first, create class, and then parent or parent model. That model is nothing but a data. Okay, so we say here observable objects. Published message. Okay, fine. This guy is very clever. Okay, so we say rather than message, I say name. Name is Mercy. Still we have some issue right here. It is because this is yet another class. So we need to put here, we need to import combine. Then it'll disappear. From this parent, I want to now use here no. I have yet another class. Class child. Child is not observable, but is a subclass of a parent. So we can say parent. And then I don't need this, but as I said here, parent sees parentheses this parent's name, right? So that we have to do here, say parent1 equal nothing but child. Let's say child1. But it should be a variable. because this is inside the struct. If you want to change it somehow later, then you need to put here state. But if we say state, then that is a single value. This CI is an object of child here. It's not single value. Therefore, you need to put here, instead of a state, you need to put state object. And then if you want to see C1 dot name, very nicely, parent C is Mercy, right? So we already linked. See here, parent name, which is an observable object, name is Mercy. And I declared subclass of that parent's child. And I made an object of child, C1. C1 has nothing here. But I said C1.name, then it is inherited from name here, right? That is inherited. Okay. And then if we want to change it, text field, and then child edits, and then text. I want to do C1 dot name, but it should be this C1 dot name. So if we want to see it, text. I need to put here something with it's not really text field, right? It is text field, but I want to make a text field style. So text field style. Let's see what happens. It's a little text field, right? So I can do, if I change that, then that is change the like this, but I want to put here more. And what parent named is I want to make one more here. State objects. Parent1 equals parent. And I will put here parent1.name. And I want to what parent is named is Mercy. I would say child. child can see what parent is named is Mercy. What child can see currently Mercy. If child is changed, then only child is renamed, because it is owned by child. It is not binding to the parent. Parent name is still Mercy, right? And child name is now changed. It'll be John. Nice, right? By this time, I want to ask if you have any questions so far. This is a little bit of the conceptual reformation from what you have understood so far. You can see the inheritance, right? Because the Mercy, and this is initially, if you do here, now that is changed. Therefore, you don't see. Mercy and parent, and the child can see the Mercy. So that is inherited. If we change it, the child name only, then it can be child name only, which is not the same as the other one. I'll bring that up. Here. Okay, here. What is the other one? I think this one. Two different ones. This is that, and I want to show this. Say, instead of 17 Pro, I want to make it simply 17, right? So two different emulator. So I have here I want to make here also let parent1 equal parent. And then lastly, text parent1 dot name. Oh, this is not binding. I want to check the binding. This is not binding. This is a subclass. Therefore, we have that. I want to see the other. Oh, here, binding. $17. So I have a binding here. Friends can see. And then I have another text. What parents our parents sees that. Not here. See, in this parent, we give text. The parent can see parent's name, right? And then we call the friend view. In this friend view, we can edit friend name. And after that, we can do, again, text. And now parent can see the name. And I want to run. Right? But if I change, for example, here, instead of Mercy, I can do John. It can be John, right? So in this case, this friend does not own the name, but bind to the parent name. So one name all the time. Initially, parent can see parents owns John, the Mercy. If we run this, Mercy, when you change this, then everything can be changed. So before and after, still parent can see parent owns the same name. This is the case here, binding. But here, observable, initially parent name is Mercy, and then child inherited, and child modify it. It can be modified. So, for example, different university, then it's not Mercy, but different university, right? Any question? Carlos, question? I think in your case, a little bit, you missed the first few, yeah, the context. So maybe, yeah, you have to catch it up to understand a little bit more here. I'm not sure if we can move forward. Let's see what else that I prepared. This is similar to that. And state objects like states, but a little bit not the value is not single value, but the reference. So visual life cycle without state objects, then one time the view, so all the view is lost. But if you place a state objects, then that view is mutable. State it's the same model we used. Observed objects that we looked at already, right? Okay, so this kind of things, possible environment objects. Oh, here, I want to give you small things here. I want to ask if Samrad and Victoria are still good. I think you what is your temperature right now? Is it hot? You need a little bit cool down, or okay to take another the concept and example?
I can take another concept or example.
Good. Okay, so you guys are okay. Let's move forward. So let me close this and create another. Stop this. I want to close this. This. This guy. This bothers me. When I move this, okay, close that. Okay, another one is if we want the data globally shared, then we can use environment objects. It is a property wrapper that tells a view, get this shared object from the environment. It is used with a class that comes from the observable object. So this is used for that. So when you declare some settings, then you can say at environment objects. So I put there, when can we use this? So it is needed by many screens. So one screen and another screen, if you want to carry over some of the environmental, the shared data, then you need to use this. Data is shared across many screens. This is something that you may understand, right? On the iPhone app, your experience, data you entered in one view, even if you move to another view, that data can be shared. So it is not automatically shared because there is two different views. So you need to make some environment objects. It is very common. For example, login user sessions, login session information. If you want to carry that over multiple different views, then you need to use this, right? Like, for example, on Amazon, items that you search, and then you click that item, and you moved to another views and another views. It's not really Amazon's, but something else. But still, you want to get the same if you want to share the value that you already had in the previous views, even if you moved to multiple different views, then you can set it up like this. Theme settings, shopping carts, app settings, authentication state, language, and locales. Once you set a particular language on one view, even if you change it to another view, depending upon your application implementation, carry that over. Network states. So it is not owned by a single view. It is shared. Like here, user John, go to profile. Then next view, you still can see John. It's not really see, but it is shared. So we need to do this. Environment object. So let's see. Struct profile view. That is view. And body. And then there's a text field. And we can say name. We need to receive that, right? So as we receive, we want to use environment object. So environment object, variable, user, and we can say user. In here, this user should be declared here in this the entry levels, so that you can do here class, and I said user, right? Let's see, I put that user, and user, it is observable object. Observable objects, and the variable name is John. Okay. Oops. So variable name equals John. There's an error because this new class came up, so we need to combine. That'll disappear. Here, that is okay, right? And I want to put variable. Oh, then I need to go to the next slide. and here dollar and user name. There's a user's name. And then text, because of this text field, I can say text field style. Text field style. That's fine. If you want to make a padding, you can do that little more space. What is this? With the text. Yeah, I need to put here text. So what I have right now is I have the profile view, so that we can ask user to enter. So right, I didn't do anything from here, right? And then I need to do here text. User equals and user add name. If you want to do this user, then you need to have here that variable user. So it should be environment variable user and user. Then can come. Something happens here. All right, here. So click report to see more details environment. This is a little bit of you don't need to worry about this. Okay. In this emulator, that happens. You can simply ignore. But if you click in this real emulator, it should be okay. Oh, right now what happens? Threadable, observable. Oh, this is observable object. So this is observable objects. So we need to make here state objects. So make another struct. Like here, root view. So root view and view. No, we don't need this. Content view. View. Okay, here. I will take that. User rather than this, state objects. State objects. Variable. Oh, should be equal sign. Okay. And profile view, spacer, content view. No, we don't navigation here. Why this guy has a navigation view here? We want to do navigation stack a little later. Yeah, we have extra here. Okay. So this content view like that. Okay. So what is this? The observable object is. Let's see. Product. Clear. Clean. I think we don't need this, right? And then this is environment objects. We need to put here environment objects, and that is user. Probably because we didn't say that. Product. Clean. Let's see how it is. Still no observable object type. Found a view environment object for user may be missing on ancestors. So where is something missing? So environment objects. Let's see if it is there. Probably. Yeah, there is a missing one. We need to put here state objects, user variable user, And then we can say here that is environment objects, and should be user, right? Yeah, we need to put here user. That should be done here in this entry points. And then when we come back here, okay, now it works, right? So user is that. I want to now navigate here. Navigate stack. So this guy has a navigation stack, open, and everything here, close, okay. And then I can put here navigation title, and then I can say profile. Then this navigation stack will make two different views can be navigated. Oh, this is not something yet. What should I do? Let's take a look. Go to profile. Oh, navigation link. Yeah, that should be done. Here, after the text, then we have to do here navigation link. Navigation link. Text to go to destination. Profile view. So when we click this, then it goes to this profile view, and we can do something. So here, go to profile, and then we can say ask them to enter. And then come back here, go to profile, and come back here. Okay. So what we have done for that environment objects, it's a little bit complicated, right? So user is a yet another type. So that type is created here, it's the user type. And because of that extra class, we put here combine. And then this name should be state objects. To make it state, this is not just a state, but state objects, which is, this is an object. When you do user, small user is a type of user. And the value is nothing but an object, which is instantiated. So it could be, you can directly say user equal user, that's fine. But more explicitly, the small user, what is the type of the user? User is a big user, which is we created here, right? That is a big user. So it can be modified later, right? If we want to, and then here from this entry point, we invoke content view. There we put the environment object user. So when we come here, content view, and that environment object is user, and that is printed like this. User is printed, and the next one is some of the clickable, navigatable. We call that navigation link. Where it goes to destination, profile view. And then text for this navigation is go to profile. So we put go to profile. Then it goes to profile view. Here, profile view. When you go next, then simply text field, enter your name. Oh, yeah, and we'll put your name there. Okay. So this is a little bit more concepts involved. So you guys needs to practice. This requires a practice. Change a little bit, see how it goes. Okay, from this environment objects. This is code, and more variable modifiers available, which is app storage and scene storages. I simply let you know there are those types available, but we are not going to go further with those the variables because there's too much, right? So I think this is everything that I prepared for today. Any question? So a little bit of exercise will be, let me think of it, whether I can give you another homework assignments or I can combine this with the next class. So a little more meaningful homework assignments. Let me think about that. But right now, this is it. Any question? Here, Carlos, I think you need to catch up a little more and also practice. Practice is very, very important. All right, if you do not have any question, I will stop here.